how do we figure out how to take you to Mars and create a self-sustaining city, a city that it's not merely an outpost, but can become a planet in its own right, and for us, thus we could become a truly multi-planet species. There are, sometimes people wonder, well, what about other places in the solar system? Why Mars? Just to sort of put things into perspective, this is an actual scale of what the solar system looks like. So we're currently in the third little rock from the left. That's Earth. Yeah, exactly. And our goal is to go to the fourth rock on the left. But you can get a sense for the real scale of the solar system, how big the Sun is, Jupiter, Neptune, Saturn, Uranus, and then the little guys on the right are Pluto and friends. This sort of helps see it not quite to scale, but it gives you a better sense for where things are. So our options for becoming a multi-planet species within our solar system are limited. We have, in terms of nearby options, we've got Venus, but Venus is a high-pressure, super high-pressure hot acid bath. If you look at a Venn diagram, there's no intersection of sets of people who want to go and can afford to go. In fact, right now you cannot go to Mars for infinite money. Using traditional methods, if taking sort of Apollo-style approach, an optimistic cost number would be about $10 billion a person. So, for example, the Apollo program, the cost estimates are somewhere between $100 to $200 billion in current year dollars. And we sent 12 people to the surface of the moon, which was an incredible thing, and I think probably one of the greatest achievements of humanity. The thing we wanted to focus on was the Raptor, and then building the first development tank for the Mars spaceship. So yeah, like I said, this is really the hardest part of the spaceship. The other pieces are we have a pretty good handle on, but this was the trickiest one, so we wanted to tackle it first. You get a size for how big the tank is. It's really quite big. Also, big congratulations to the team that worked on that. They also were working 7 days a week to try to get this done in advance of the IAC. So that we managed to build the first tank, and initial tests with cryogenic propellant actually look quite positive. We have not seen any leaks or major issues. This is what the tank looks like on the inside. So you can get a real sense for just how big this tank is. It's actually completely smooth on the inside, but the way that the carbon fiber plies lay up and reflect the light makes it look faceted. So as we thought about the system, and the reason we call it a system, because generally I don't like calling things systems because everything's a system, including your dog, is that it's actually more than a vehicle. There's obviously the rocket booster, the spaceship, the tanker, and the propellant plant, the in situ propellant production. If you have all of those four elements, you can actually go anywhere in the solar system by planet hopping or moon hopping. So by establishing a propellant depot in the asteroid belt or on one of the moons of Jupiter, you can make flights from Mars to Jupiter no problem. In fact, even without a propellant depot at Mars, you can do a flyby of Jupiter without a propellant depot. But by establishing a propellant depot, let's say Enceladus or Europa or any of there's a few options, and then doing another one on Titan, Jupiter, Saturn's moon, and then perhaps another one further out on Pluto or elsewhere in the solar system. This system really gives you freedom to go anywhere you want in the greater solar system. So you can actually travel out to the Kuiper Belt, to the Oort cloud. I wouldn't recommend this for interstellar journeys, but this basic system, provided we have filling stations along the way, means full access to the entire greater solar system.